All right, good morning, everybody. So, let's see, lots of stuff to talk about today. Where should we start? Any questions before we get going? All right, let's start off talking about the midterm because that's coming up Friday. So let me give you some really important information about the midterm here. Um, so it's Friday. It's going to be held during class time. You do not need to log into Zoom, but I recommend you log into Zoom. But it will be a Canvas quiz, okay? It's not the midterm topic that you see on there right now. That's just a placeholder. But Friday at 10 o'clock, a new assignment will open up that'll be labeled midterm. It'll be a quiz. Um, if you have questions during this, if you're not sure what I'm asking for, or what's an appropriate answer in some question or something like that, you have a few choices. You can send me a private message on chat through Zoom. That would be the best way. Okay. If you can't get into Zoom, if you're kicked out, something like that, you can try to send me an email message to my regular email account, not my Canvas account. Okay. I'll keep my Clark email open, and if you can't get into Zoom, right, we can talk through that and figure out what to do. But hop into Zoom, and also sometimes someone will say, "Hey, question 5 is impossible. Is there a mistake?" And I'll look at it and I'll say, "Oh yeah, this should be this instead of that," and I'll send that out to the people in Zoom. If you're not logged into Zoom, I have no way of getting that information to you, and you're putting yourself at a disadvantage. All right. So hop into Zoom, keep the chat window open there, but the quiz itself is on Canvas. All right. So question: what are some of the Linux commands we need to know for the midterm? All the basic stuff that you've been using in Linux. So know how to edit a file, how to compile a file, how to copy a file, move a file, delete a file, how to initialize a Git repository, add a file to the staging area, commit it, push it to GitLab. What else? Basic commands, echo, date, things like that. Plus all of the shell scripting stuff, which we'll talk about separately in a minute. Makefiles will not be on the midterm. All right, thanks for asking. Makefiles we just started talking about yesterday, so those will not be on the midterm. They will definitely be on the final exam, though. All right. Reminder once more, if you write bash code on the midterm, it's got to follow the constructs that we've been discussing in class and that are posted in the Canvas how-to for bash. So this means that you're not allowed to use for loops. If you do arithmetic, you've got to use it the way we've been talking about, which is $paren. If you use if statements or while loops, they've got to look exactly like the way we've been talking about it. If space, bracket, bracket, space, condition, space, bracket, bracket. New line, then, new line, body of the if, new line, phi, etc. The conditions themselves have to look exactly like we've been talking about. If you're comparing strings, 2 equal signs or exclamation equal. If you're comparing numbers, dash EQ, dash NE, and so on and so forth. So someone asked, can we log into the Linux server during the midterm? So I have no way of policing this. Okay, well I can police the Linux server. But you're allowed to use your textbook. You're allowed to use your notes, which includes copies of your programs and ODPs that you've already written. But that's it. Okay, and you're allowed to use an editor to type in your answers and then copy and paste them. So no other websites, not the Linux server, no Chegg or Friends or chats or anything like that. Textbook, your own notes, and an editor. And this is honor system. All right, and the first question of the midterm will be an honor statement. basically saying that you understand, those are the requirements and the things you're allowed to use and not allowed to use, and you have to type in your name in a entry spot to say that you agree to the honor statement. If you don't answer that question, it's an automatic 0 on the exam. So you've got to answer that first question by putting your name in the box. All right, what else can I tell you? Let's see. Can we just use our ODP code on the Linux server if we don't have it anywhere? No, download it and add it to what you consider to be your notes. Print it out as a PDF or just save it as a text file or something like that. Again, I can't police, what people are using for their notes, so I can use a lockdown browser that, prevents you from going outside of Canvas and all of this nonsense, and that doesn't stop you from having a cell phone where you talk to friends or something like that. So we're strictly going on our system, but yeah, keep everything just on a a file of notes or however you want to organize it. You don't have to print stuff out, but notes and textbook, and then an editor. All right. So there'll be a series of questions. There's 4 programming questions and then a few short answer questions. For the programming questions, again, I don't recommend typing directly into Canvas. If you get kicked out of Canvas and you lose your answers, right, then you're going to have to start over again. So write your code in an editor. Okay, pick your favorite editor. Don't use an editor that writes code for you. Okay, write the code yourself. Write your answers that way and then copy and paste them into Canvas. Okay, and to help you with this, I have made available a very low-key practice midterm. So this is not graded, this is not required, okay, but this is a way that you can work on this stuff and get some practice with copying and pasting from your favorite editor into Canvas. So for example, question 1 just says, write some C code to say hello. Well, I don't know how you're going to do this. It depends on your setup, but you need to figure this out ahead of time. So let's say I'm using VI and I'm going to say, okay, so let's say I've written this up, and this is my beautiful code that I want to paste in for my answer to my question. Okay, so I would probably, for me, I can just highlight this to grab it, and I'd come in here, and you could say Control V. Okay, well that worked pretty well. But if you use a different editor and you paste it in, you might find that everything is left justified. Okay, or you might find that everything is double spaced. Or you might find that some other change has been made by the browser to your editing. So I want you to use this to experiment with how am I going to paste my code. And some things to try: Control-Shift-V will change how it's pasted. So for example, that gets rid of the formatting for me. But also over here, if you go to pre-formatted, that will change the way your code works. So here, if I Control V, the indenting is really nice, but it's double spaced. If I Control Shift V with pre-formatted, this looks pretty much exactly like what my original code was, right? It's indented 2 spaces per line and so on and so forth. If you use tabs, tabs can be good or bad. Okay, if I have tabs in my file over here, it's going to look differently. In VI, you can say :set expand tab, which will replace your tab with spaces. But figure this out before Friday. Okay, don't paste your first piece of code and suddenly realize that everything you paste comes out on one big long line, right, and is not going to look good. So figure this out ahead of time. you're doing all your classes online, probably. If you haven't cracked this nut yet, it's one you need to figure out at some point. Microsoft Word, good idea or bad idea? I would suspect not such a great idea, but give it a try. It probably depends on your version of Word and how you're pasting, and maybe on your browser, and who knows what else. So experiment. I don't have anything on this exam, I think, where you're modifying code, but if I do, you would typically see some code here, and you'd want to be able to copy that and paste it into an editor, and then make some modifications on it, right? Which I can do with just Control-Shift-V. Also, be aware that if you're in here and you're typing stuff and you hit a couple of tabs to indent your code, right, the browser picks up those tabs and moves you, and if I hit a space bar, right, it's going to do something weird. So figure this out before Friday, okay? That's what this practice quiz is for. If you already know how to do this, if you've done this before, don't worry about it. There's no points for this. It doesn't count for anything. It's just there as a tool to help you. Can we use our GitLab repositories as notes? Yeah, as long as they're your own files. I'm okay with that. But they gotta be your own repositories. So if you don't want to download all of that, that's fine. All right, any other midterm questions? All right, yeah, that's cool. All right, so that's about all there is to say on the midterm. And again, that's Friday at 10 o'clock. It's a 50-minute exam. I'll leave it open until 10:55, but at 10:55 it will close. And it's set to allow multiple attempts if something goes wrong and you submit it early. Before you finished it, just keep going. Okay, if you have time to put all your answers in the final submission, that's fine, but it should keep all of the old submissions as well. And if I see 2 entries for you, right, and some of them are missing from the second, I'll go back to the first and pick up the missing ones. Again, you can always hit me with a chat in Zoom during the exam and ask questions. Let me know what's going on. All right, so I've posted homework 6. So this is your 3rd programming assignment. And this is a high-low game written in C. So I've posted a very detailed discussion of this assignment. And let me start off by just showing you what we're after. So I've put a sample executable program on the Linux server. And it's sitting under /temp/main. And if I just run this and it just says /temp/main, right? Here's what it does. Basically prints out a greeting, says it's going to think of a number between, it's going to ask me to think of a number, and it's going to try to guess what that number is. Okay? And since I just ran it without any command line arguments, it's asking me to think of a number between 0 and 100. So it says, please think of a number between 0 and 100. Hit enter when you're ready. Okay, so I'm thinking and I'm thinking and I'm thinking of a number. And I got a number in mind, so I hit enter. And it's going to say, I will guess your number in at most 7 guesses. And it says, guess 1 is 50. Is that high, low, or correct? And I need to tell it whether that guess 50 is high, low, or correct. So let's say I'm thinking of the number 80. Okay, so I would say this is low. 75, that's low. 88 is high. 81 is high, 78 is low, 79 is low, 80, that's correct. And it turned out it actually took it exactly 7 guesses to get the right answer. Of course, if the first number I think of is 50, right, and it says, is it 50? Well, yeah, that was correct. All right, so yeah, this is the game of binary search. You can also run this with a new upper limit. So if I want to play high-low between 0 and 10,000, right, it'll say, please think of a number between 0 and 10,000. So let's say I'm thinking of the number 42. All right, so it tells me it's going to take at most 14 guesses. All right, so 5,000 is high, that's high, that's high, that's high, that's high, 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 that's low, that's high, that's high. 42 is correct. So it only took 11 guesses. All right, you can also run this with a pair of arguments, and that specifies a range of numbers to play the game between. So let's say we want to play high-low, where I think of a number between 300 and 500. All right, so it says think of a number between 300 and 500 and hit enter. And, you know, I'll think of the number 401. So I'm ready. It's going to take at most 8 guesses. 400 is low. And 401 is correct. Alright, so we'll go over the algorithm, but yeah, basically the algorithm is just cut the range in half each time. But there's very specific ways you need to do this, okay? You also need to do all the obvious things like, you know, if you don't put in a valid integer, print an error message, exit. Alright, 30.0, not a valid integer, exit. If the first number is not bigger than the second, is not smaller than the second number, that's an exit. 100, 100, not a valid range. 100, 101, that's fine. If you only have one argument, and this is not a positive integer, that's an error. If it's a 1, that's okay. If it's not, you know, a correct response, that kind of thing. And if you run it with no arguments, it just goes between 0 and 100. Alright, it says hit enter when you're ready. If you type extra stuff there, I don't care, you just need to hit the enter key to start it. This is just giving you a chance to think of a number before it starts guessing. Alright, so you hit enter. Your response here has to be H, L, or C. Okay, so if you type anything else like high, or the letter H with an uppercase, or a space with an H, or gibberish, it's got to be H, L, or C. Alright. The other thing is cheating. So let's say we're playing between 0 and 100, and I'm thinking of the number 78. Alright, so 50 is low, and 75 is low, that's high, that's high. 78, well, I don't want to lose the game, so I'm going to say 78 was too high. Alright, well 76, I'll say that's too low, and I'll say that's too low. And it knows that something happened. So it says something is wrong. Did you forget your number? Parentheses, you are cheating. And it exits. Alright, so that's the behavior of the game. Okay, I want to go through the written specification of it now. It's 4 pages of goodness. But this is the essential behavior, and then I'll show you how I'm going to grade your assignments. Okay, and there's no reason in the end that when you turn this in, if you think you got 100, you should get 100. Okay, if you follow the specification and you make sure that you hit all the grading points perfectly, you should get 100% on this. If you can't get something to work, if you can't figure out the algorithm, that's different, right? But hopefully in that case, you figure that out early and you've come and talked to me and gotten through that. So let's take a look at the written specification. Alright, so you're writing a C program to play high-low, which is a number guessing game. Very important, the user thinks of the number, the program tries to guess it. Don't code this backwards. Okay? the human user is thinking of a number, the program is trying to guess it. Alright, program has to be an executable named main. And the number that you're guessing is always constrained between two numbers, low and high. They're integers. 3 ways to run the program. With no command line arguments, the range is 0 to 100. All these ranges are inclusive, which means 0 and 100 are also legal options. So if I just do my default main, and I'm thinking of the number 0, it should be able to guess that. So 50 is high, that's high. There's my correct guess. Alright, so all these ranges are inclusive. With one command line argument, the low end of the range is always 0. The high end has to be a number bigger than or equal to 1. Alright, with 2 command line arguments, you're specifying both the low and the high. The low has to be bigger than or equal to 0, the high has to be bigger than or equal to 1, and bigger than low. Alright, so if you just say main, that's 0 to 100. If you say 25, that's 0 to 25, 100 to 200, and so on. Okay, if any of these integers are invalid, print an error message and exit. And this is the very specific version of parsing integers. So if you have extra stuff after the integer, that's invalid. So you have to use this %d, %s business that we talked about last week. Alright, gameplay. Start by asking the user to think of a number and hit enter when they are ready. So if you say main 200, say think of a number between 0 and 200 and hit enter when ready. Okay, you can print instructions in the beginning too. Once they hit enter, then tell them how many guesses it's going to take. I will guess your number in X number of guesses. And then the gameplay starts. You say guess number, starting with guess 1, followed by the actual guess. Ask the user if that's high, low, or correct. Again, if they don't say H, L, or C, keep asking them H, L, or C, high, low, or correct. If the guess was correct, game's over, you can exit. If the guess is too high or low, the program should adjust its guess and then print out guess number 2 followed by its second guess. And then wait for H, L, or C, and keep doing this. Alright. Game should detect if the user is cheating, and if it detects that, tell the user something's wrong and exit. Alright, the algorithm. This is super, super important. And I've given versions of this assignment in the past, and half the class does not follow this algorithm. And they spend huge amounts of time trying to figure out why they can't detect cheating, or why they can't guess the correct number if it's 100, or if it's 1, or why it takes so many guesses, okay? This is a very precise algorithm, and you have to use this algorithm, okay? If you come up with a better way to play high-low, that's great. You got to use this algorithm, okay? So here's the whole setup. The game is being played between 2 ranges, low and high, okay? Your first guess is low plus high over 2, converted to an integer. So if you use integers for all of these variables, just set guess equal to low plus high over 2. It will do the correct rounding for you. Okay, so let's say your guess is called guess. If guess was too high, then you want to change the high variable to guess minus 1. That minus 1 is absolutely critical. If the guess was too low, then change the low variable to guess plus 1. And once you've made one of these adjustments, if low is bigger than high, the person is cheating. Okay, that's the whole algorithm. So let's say low equals 1 and high equals 20. What's your first guess going to be? Your first guess is going to be 10.
We can't see what you're writing.
You are right, thank you. Alright, so let's say low is 1, high is 20, your first guess is going to be 10. And let's say I'm thinking of the number 16. Alright, so you're going to say, is your number 10? they're usually going to say that's too low. I'm going to use uppercase here so that you can tell my L's from my 1s. It's going to be too low. I'll just write it out. All right. If it's too low, what do you want to do? If the guess was low, change low to guess plus 1. So change low to 10 plus 1, which is 11. You got to add 1, right? If 10 is too low, there's no point in considering 10 again. So the smallest our number could possibly be is 11. So now our guess is going to be 31 over 2, which is 15. So we're going to ask if it's 15. That's going to be low. What are we going to do? We're going to change our low variable to 15 plus 1, which is 16. Our guess is going to be 36 over 2, which is 18. And we're going to ask, is it 18? And we're going to be told that's too high. Well, if your guess is too high, then change high to guess minus 1. So our guess was 18, that's too high. We're going to change our guess to 18 minus 1, which is 17. And then make your new guess, which is 16 plus 17 over 2, which is going to be 16. And so we'll ask, is it 16? And at that point, the user should say correct. Now, if they decide to cheat, if they don't want to be called out, they might say, no, 16 is too low. Well, if it's too low, then you're going to change low to guess plus 1. So we're going to change low to 17. And we're going to ask if the number is 17. Now, you'll observe that at this point, low and high are equal to each other. I urge you not to try to use that to detect cheating. Okay, I think once I've seen somebody use that correctly, and at least 15 times I've seen people try to do that and not get correct. Cheat detection. All right, so just keep playing the game. Low is 17, high is 17, our guess is 17. We ask if the number's 17. It's gotta be, right? There's no other possibility because 18 was high and 16 was low. But let's say they say that that's too low. All right, if the answer is too low, change low to guess plus 1. Guess is 17, low is going to change to 18. All right, anytime that you adjust either low or high, do this check. See if low is bigger than high. All right, and right now, low is bigger than high. That's it, you know something went wrong. All right, so that's the cheat detection or the detection that something went wrong. All right, how many guesses will it take you to figure out this number? The formula is 1 plus the log base 2 of 1 plus high minus low. All right, so what does this mean? This means this means you calculate this number. This is an integer. Change it into a double. Calculate the log base 2, add 1, turn that into an integer. That's the number of guesses you need. All right, so how do you find log base 2? Log base 2 of x is log base anything of x divided by log base anything of 2. So you get to use some math. All right, this means you're going to have to include math.h. And when you link, you're going to have to say -lm at the end of your GCC command when you're building your executable to link in the library that contains the logarithm function. All right, and you can do this with just plain old log. If you do a man on log, there's a double log, there's a log f for floats, there's a log l for longs. You can just do plain old log. use a double argument, take a double return. This is the natural log, log base e, but again, if you take the natural log of x and divide by the natural log of 2, that gives you the log base 2 of x. And so this is being used to calculate how many guesses it's going to take to figure out your number. So 1 plus log base 2 of 1 plus high minus low. And again, there's a sample executable. You can play around with this and see exactly what that prediction is. And it's always possible that I made a mistake here, but I checked this pretty thoroughly last night, and after a few tries, I settled down on this formula, and I think this is always going to work. But you know, if you're trying this and you've got questions about it, definitely let me know. All right, so sample executable under /temp/main. Okay, other program requirements. So this is a critical part. I need your program to be written in a very specific way. All right, so I want a separate file named intro.c containing a void function named intro, which prints out a greeting message and basic instructions at the beginning of the program. I want a file named predict.c that contains a function, integer predict, that takes 2 integer arguments, low and high, and returns this number. Okay, the number of guesses is going to be required. I want a file named getAnswer.c containing a function named getAnswer, takes no arguments, returns a character. And what that function does is it asks the user to enter HL or C, takes a line of input, makes sure it is exactly a single character HL or C. And if it is, then it returns that character. Otherwise, prints a message saying, you know, please enter HL or C, and it keeps looping until the person types in either H enter, L enter, or C enter. All right, and then a file named main.c containing your main function and any other necessary code. Okay, I didn't put it explicitly in here, but your main function has to use these functions. You can't write these functions and then not use them. Okay, so your main program should, you know, call intro to print the intro. It should call predict before it tells you how many guesses it's going to take, and every time it wants an answer, it should call getAnswer. All right. I also want at least one .h file containing the function prototypes for at least these 3 functions. You can put anything else in the .h file that makes sense. You can have more .h files, you can have more .c files, and you can certainly have more functions anywhere that you want. Okay, but I got to have a file named intro, a file named predict, a file named getAnswer, uppercase A. Okay, these are extremely specific. These are worth points. If you call this getAnswer with a lowercase a, you're going to lose points. All right. This is, you know, modeling in some way. You're working on a team. You're developing pieces of a larger project. If you write a perfect getAnswer function, but it's not called getAnswer with an uppercase a, it's not going to go into the build with other people's pieces, and it's going to get kicked out. It's going to delay the project. It's going to affect your raise at the end of the year, and so on and so forth. So this is critical stuff. Okay. You also need a README file that's got to contain at least your name, the class, CSE224, and your section number, the date, and a description of this whole program in your own words. Okay, and then anything else you want to put in there. So this has got to be included. I need a good makefile. We spent all of yesterday talking about what constitutes a good makefile versus a poor makefile. You got to have a good makefile, meaning it selectively recompiles only the files that it needs to when something changes. All right. It should build main as its primary target, so that should be the first line of the makefile is the dependencies and recipe for building main. And it also needs to have a clean target, and the clean should selectively remove the appropriate object files in the executable. Don't just remove star.o or star.c. All right, Git requirements. So this has to go in a Git repo named HW006, uppercase. Make sure Nick Macias is added as a reporter. and it's got to be available for download by the due date and time. Your Git repo should contain the following: your README, your make file, all of the .c and .h files, nothing else. Okay, don't push object files, don't push the executable, don't push test code. Okay, I want only the .c and h files that are in the make file, plus a README. Alright, so here's the good part. This is the grading rubric. Okay, you got to pay real careful attention to this. It is possible to write a program that plays high-low perfectly, submit it, and get 10 out of 100 on this assignment. Okay, because playing high-low is 10% of the grading here. Okay, so here's everything you got to do. The executable has to be named main, lowercase, 4 letters. That's worth 5 points. It has to run correctly with no arguments, meaning it takes the range to be 0 to 100. That's worth 5 points. Runs correctly with a single argument, meaning it makes the range from 0 to whatever that argument is. Runs correctly with 2 arguments, meaning it plays between those 2 numbers inclusively. Has to handle all possible errors in command line arguments. That's worth 7 points. If there's a case that it doesn't handle, you don't get the 7 points. Okay, so these are all sort of binary. They're you get the points or you don't get the points. So perfect error handling of command line arguments, 7 points. Prints a greeting in the beginning and tells the user what the range of numbers is that you're playing with. That's worth 2 points. So, you know, think of a number between 0 and 100. Waits for the user to think of a number and hit enter. That's worth 3 points. If it just jumps into its first guess, you don't get those 3 points. Okay. Tells the user how many guesses it's going to take. That's worth 10 points. And that's got to be in your own function, that predict function. Alright. For each guess, prints out the guess number followed by the actual guess. So this business here, where it says guess 3:88, right? So putting it in that format, that's worth 5 points. Uses the correct algorithm for making the guess, meaning you're picking your guess to be halfway between high and low. That's worth 10 points. Okay. And it responds correctly to H or L. So if you say that's too high, set the new high range to be guess -1, and so on. That's the actual high-low part. Okay. That's your 10 points if you turn in a good high-low game that doesn't follow any of these other steps. Okay. Needs to respond correctly to C, so it knows that that means it was correct and the game's over. Prints error messages if anything other than H, L, or C goes in. That's 6 points. Detects cheating, worth 8 points. And then these last points are based on the structure of the project itself, so it has to be split into the required pieces. The separate .c files, the .h file, that's 11 points. A good, clean make file that meets all the requirements, that's 11 points. And the Git repo has all of the necessary pieces and no extra pieces, that's worth 5. Okay, so that's a total of 100 points. And common sense here, right? If I say make and your program does not build an executable, you're not going to get any of these points. Okay? Because then the program does not, you know, run correctly with no arguments, 1 arguments, 2 arguments, and so on and so forth. You might get points for splitting it into correct pieces. Okay? But the rest of this is, right, dependent on being able to run your program, have it start, and so on and so forth. Alright, if you have any questions about this, you got to talk to me ahead of time. Don't come to me afterwards and say, well, you didn't say such and such, right? If you've got any questions about this, talk to me now. This should be totally clear. And you can always go to the sample executable, right, and just run that if you have any questions. So what happens if I make the first number bigger than the second one? Right, that's an error condition. Unfortunately, I can't post, you know, a sample make file or that kind of thing, because that would give away, right? But we talked about that yesterday. So yeah, all of yesterday was talking about make files. So we went through specific examples and And yeah, there's a sample. So that's a sample of a good clean make file, right? Selective compilation, it's got a clean option. You don't need an install option for this. But it's got a clean option. It builds, main3 as its primary target. It compiles the C files to object files, and then it links those together. All the dependencies include file dependency as appropriate, and so on and so forth. So certainly, right, if you have questions about that, talk to me about it. You can ask questions in class, you can come to office hours, and so on. This stuff is going to get harder and harder to talk about in email. Okay, we're getting into larger programs, more pieces, more issues about how things are done. So office hours are going to be increasingly the best way to ask questions and get help. All right, good. Other questions? So that's posted on Canvas. It's due a week from Friday. So, which is, I believe, the 30th. Yeah, the 30th, 8 a.m., same as usual. So again, if you want to push a repo over in the next day or two and ask me to look at it, I'm happy to do that. To make sure that I have access to it. I'll fix a couple of typos in here and repost this, like where I said don't remove star.c, I meant star.o, and so on. All right, no other questions? How do we delete stuff off of our Git repositories? So inside a repo, if you want to remove a file, you want to do git rm. And if you want to move a file, rename it, you say git move mv. So if you have a repository and you just remove a file with rm, and then you try to push it over, sometimes you get messages about things being out of sync, right? So, so git rm will remove it in a way that lets Git know that this has deliberately been removed. And someone points out if you do git rm -- cached, it'll actually keep the file around, but just remove it from Git. Another thing you can do, I don't think you need to get into this, but you can make a git ignore file in the top level of your repository, and you can list files in there that you do not want to get added to your staging area. And then even if you try to add them, like if you say git add star, it would exclude those. It's probably better to just be very selective in what you add with Git. So, and you can make a script. If you've got 6.c files and a .h file and a README, you can make a script which says, git add and lists all of those files, and then git commit, and you could put, a canned message on it or make it an argument to your script and so on, and then git push, and then anytime you've got, a change to one or more of your files and you want to commit it, just say, do git, whatever you call your script, and it'll go ahead and do all that stuff for you. Let's see, will Git save it as an older version if you just use git rm? Not sure what that means by saving it as an older version. It'll remove it from your repository, but the old versions of your repository will still have it. You can still go back and check out an older version and see it there. All right. So I wanted to talk more about Git, and we've only got 5 minutes left. I'm going to go ahead and start it. So let's talk about managing multiple Git repositories. Hopefully you're running a Linux system on your own hardware, so that you have, a way to do local development and testing, and also, play around with Linux more. But we also have the Linux server, and you have accounts on there, and that's where stuff gets tested. So even if you're developing on your own system, you definitely want to test it on the Linux server, because there's differences in compilers and environments and things like that. So let's go ahead and play with some of this stuff. Whoa. I don't know what the heck I'm doing. Alright, so I got a directory over here with some files in it. Hopefully you're starting your Git repo before you start making files, but I'm going to do this backwards. So I'm in this directory. I want to put this under Git control, so I'm just going to say git init. I'm going to say git add star.c star.h and make file. And I'm going to say git commit. Terrible comment, just initial check-in. So I'm all set here. I've got all my files checked in, nothing uncommitted. I want to push this to GitLab. Okay, so git remote add origin git at gitlab.com colon your git user ID and then your project. I don't know, I'll just call this section A dot git push origin master. All right, so there we go. I've got my repository pushed over to GitLab. All right, so let's say I come home and I want to work on my my project that's on the server, but I want to do it on my local machine. So this is my home machine, and I want to work on. I already forgot the name. Section A.git. Okay, I can make a copy of this. So here's all I have to do: git clone git it gitlab.com colon Nick Macias section A.git. And this will create a subdirectory under my current directory with the name of that repo, and it will copy that repository. It's a little slow. Erase. 45 seconds. Wow. Well, anyway, once this finishes, this will make a subdirectory called section A.git. And if I go into that directory, it will have a copy of my whole repo from the Linux server in this case. Awkward. All right. Well, trust me, this will work. So we'll play with this tomorrow. Okay. What we'll do tomorrow is we'll do this again. We'll pull down the Git repository. We'll make changes to it here on my local machine, and then push those back up to GitLab, and then pull them back down to the server and go back and forth like that. And we'll see how to do that, just to sort of keep 2 or more repositories in sync. This is also good if you're working on group projects. All right. We're out of time. I'll let this run and finish, but we'll do this again tomorrow. All right. Have a good one. Talk to you next time. Bye.